My boys, we have a wonderful machine in our possession, having until we fully explore the full potential of this miraculous machine. We shall tell no one.
Hello, welcome to the wonderful world of random sequencing. Today we're going to be looking at a sequence called the 14 is equal to 27, or the 27 is equal to 14. Now, why is that the case? Because the 27 is equal to 14 because the 27 carries the statement 2 sevens, and 2 sevens is equal to 7, 7. And 7 plus 7 is equal to 14. So as you could see here, the sequence start from here, go to here, 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 and here, and then here, here. So as we could see here, at the end, this is sequence 6. So we have a 14. So the sequence has to be satisfied within a half step. In most cases, it happens within a half step. So this is a half step. From here to here is a half step. So somehow we're going to get a 27. Where is it going to happen? Is it going to happen here? Or is it going to happen here? We're going to assume that it's going to happen here. And if we did, it played out 27. So that 14 is equal to 27. And one thing to know about sequencing is that when you establish a theme, it gets played out over and over and over again. Once the theme has been established, in this case, this theme is called the 14 is equal to 27. So, notice over here, if that is going to play out a 14 of some sort, we already have a 4 here, right? So that's going to link to a 14. So how do you make a 14? You can make a 4 linked to a 1. That makes a 14. But this is a symbolic 14. The 1 linked to a 4, or 4 linked to a 1, is a symbolic 14. You could also make a 4 by forming a 10 here. So what you have is 4 plus 10 equals 14, or 10 plus 4 equals 14. So we're in this situation, and we're assuming, where the 4 is, we're assuming that it's going to play out either a 1 or it's going to play out a 10. And the very place where this relationship could be established is going to be right here, because it's a half step away from here and here. As well as this square is also a half step away from here and here. So we're assuming that either a 1 or a 10 is going to play out. No, so those are the two options, either a 1 or a 10. Now, it didn't happen here. It played out to 26. That is okay, because we know now that it's going to play out right here. So the options, we're going to play either a 1 or we're going to play out a 10. As you can see, it landed on 10. Why? Because 10 plus 4 equals 14. Just like here, 14 is equal to 2 sevens. 27, I mean, and 27 is equal to 14. So the themes get played out over and over and over again. So we're going to continue with this theme. So the question is, the very next sequence where we could play out this theme is either here, or here, or here. So we're going to assume that's going to be played out here. So now, is it going to play out a 27 is equal to 14? Or is it going to play out a 14 is equal to 27? So the options on this square right here is either going to be a 4 or a 27. If you play those two options, you landed on 4. So now what happens is 27 is equal to 14. That's great. So this theme, so now we see that we're kind of setting a path, a diagonal downward path that goes to the left. straight line, just like that, to here, to here. So now we're in this square here. And we're going to assume that it's going to be a 27. But one thing about Mother Nature is that it doesn't get redundant. It throws a curveball. In this case, we know that if Mother Nature throws a curveball, we know that it's going to be a number that has a 7. Because if you play a number that has a 7, like either a 7, 17, or a 27, what you have here, like this is the 12, right? 12, 17. So what you have here is a I statement, I 27. I am 27. So this is 27. And over here, if we were to play out a 17, you have the 1, 1, which is the equal statement. And you have equals what? 27. So this number is also 27. This number is 27. This number is 27. Now, you could, the last option would that it would play out a hard 27. This is a hard 27, hard as in H-A-R-D, or it's a natural 7. So it'll play out a natural 27. So those are our three options. You're going to play all 7. So a 7, 17, or 27. And it landed on 27. I mean, sorry, it landed on 17. So this number together represents 27. So if we follow diagonally this way, straight path, we have to assume that it's going to play out a since it already played out a 27, it has to land to on a 14. So if you look at the relationships of where what is related to the 27, we know that the 27 is linked to a 14. It's also linked to a 410, right? But it also could link to a 1. So our options in this particular field is going to be a 1, or it's going to be a 4, 10, and 14, because it makes because we already know that if it were a 4 linked to a 1, that'll make 14. If it's a 4 linked to a 10, it's going to make 14. So our options are 4, 10, and 14, and 1. So it landed on 14, as you can see right here. So this 27 sequence to a 14, just like that. So so that was the grand finale. This is like the end of the sequence. I hope you enjoyed this. And folks, as always, please click the subscribe button below, show some love, give me some thumbs up. I have links below with PayPal and Patreon. And I will see you on the next wonderful world of random sequencing.